Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're gonna talk about game development. In last episode of Computer Wednesday, we talked about CGI, so let's extend it a bit. So in today's episode, we're gonna talk about 3D video game. I'm not touching about 2D, I'm talking about 3D. Now, to understand the context of it, you have to understand it this way. Entertainment industry, it's a big industry. We know TV stars, we know movie stars. Gaming, on the other hand, while you may not know the people behind the games, but it itself is a huge industry in terms of financials. It's huge industry. To classify basically video games, we have a title known as triple A titles. Basically, triple A means you spent a YOLO amounts of money. So far the biggest amount of money spent on a single game is around $500 million in Destiny, and I would not be surprised some other game is coming that is gonna exceed that. So 500 million, to give you a context of it, think of this: end game, Avengers Endgame and Infinity War costed that kind of money. So 500 million is no joke. Like almost all Batman movies are half that. So where do we quote unquote sell these games? There are three primary means of income right now. One is PC, another is console, third is mobile. These three are the biggest avenue as of now. There used to be handheld portables, but they are no longer, they are basically quote unquote being replaced by mobile. Now the money involved here, you may think, okay, still millions of dollars. No, but the amount of money dealt by game studios, stock markets and all that, they go into billions of dollars. So it's not something like chump change. No, it's expensive. Now, thankfully, even though the complexity, I worked in this industry for around 2.5 years, and worked in some big company games like from Sony, Microsoft, Starbreeze and all that jazz. So it does take insane amount of talent and pool of people. Like we are talking about around 200 people to 600 people, but it can be done by single man. And sometimes it happens, it's not guaranteed, but sometimes it does happen where a small game can make a big money. Like for example, Angry Bird was, like, if I'm not mistaken, was like 40th or 20th or 40th attempt by the small company to make that. They were like, that was their last draw. Like we cannot make any, like none of their games were making a big hit, and they were not financially well, but that game blew up, and they're like, so it happens. So this world is completely different. Now in last one I talked about vertex, triangles and all that jazz, so we call that mesh. Now mesh generally requires two kind of toolkit. First toolkit is 3D, and then we have 2D. Now you might be like, why the heck you need 2D? Think of it this way: you design a 3D mesh, you have to paint it. For painting, generally 3D is the best option. So we start with 3D modeling. Once the modeling is done, we generally texture it. So that goes into 2D phase. Now, in case of what tools are most popular is Maya. Second, I would say 3ds Man. Then you have Blender. Thankfully, while Max and Mayas are very very expensive tool, Blender is free. Then we come to 2D aspect. In 2D aspect, we generally utilize Photoshop. Again, super expensive tool, but if you're like, hey, I don't have money, you can go to GIMP route, which is surprisingly competent nowadays. Now these are like bare minimum. This is like bare minimum you need to mod in order to make a 3D asset. Then sometimes people add bit more. Nowadays it's a lot more has been added to video games and all that, because you can notice, like if you play like very old game like IGI and very old games, you would notice like characters were like they did not have hands or fingers, they just had like blob like this. Nowadays they have a full hand animation, face and all that jazz. So many times we take the mesh made in this 3D package, we import them, basically export them to ZBrush, and in ZBrush, like artists sit down and they sculpt it. The amount of detail that can be created in ZBrush is bonkers, and I mean bonkers. Like they will take a low poly mesh that looks like a low poly mesh, you will be like, and then they can make it into such a high detail level where it's like, dude, that looks like a photorealistic face. When you see people doing face swap with in movies and all that, that's how it's being done. ZBrush is like on a whole different level. I hate that tool, but it's on a different level. Then texturing, like that 2D part, it's very tedious. Like 3D, many people like it, I also like it, but 2D part in terms of texturing and all that, I hated it. Like again, because I sucked at it, that's why I hated it. But even then, like even if you find people who are experienced in it, they're like, dude, it takes insane amount of it. Like you can make a building, like, yeah, it took 2 days. How about texturing? Yeah, that will take 10 days. So for that reason, other tool set have been created, like Substance Designer specifically. It allows you to texture without ever touching a paintbrush. So like virtual paintbrush is surprisingly awesome. So this is how we create the basic bare minimum 3D. Then all this is just basically stuff to make that stuff interactive, we are talking about video games after all, we generally go into rigging and animation. Now rigging department generally simply means you are giving joints. Basically, okay, this is how this bone is gonna move up and it's not gonna bend backwards, so you have to design your character in such a way. Or let's say hard objects like tanks, planes and all that, you have to design in such a way that it can move, but move within reason. Basically, if you're designing in such a way that it should move like this, it should not end up moving like this. So those are done in rigging phase. You add bones to it. So whenever you see game characters, they have bones. You see a tank, it has bones. Yeah, it sounds weird, but it has bones, and those bones are controlling how it's gonna interact with the environment, and that's limiting it. That's why it's gonna behave how it's supposed to be. It's not a CAD software. Game engines are not a CAD software, so they're not like, oh, this is how suspension is gonna behave, like this is how much friction, and yeah, that's not happening. So we use bone as a compromise. Bones generally control the stretching and rotation primarily. Then we take that basically rigged model and then we animate it. Animation, where it's like, okay, you got something that can behave in such a way, but it has to behave in such a way. Like, let's say character is talking, so to get a talking animation, people do generally what we call phonemes. Face will be zoomed in and the animator will they're like in Indian, I'm specifying, I'm talking about English language, there are like 25 characters, but in terms of phonemes, the sounds that you can create, there are only few. So those are like 12 if I'm not mistaken, and animators are gonna make that. So whenever somebody says like, okay, this is the dialogue, you're gonna splice all those things together and tada, you're gonna have a mouth animation. Or sometimes you can do actual real capture, and that also the capture in whenever you see the behind the scene, it looks like, oh, they motion captured someone and just plonked the information. That does not work like that. They're just like, it always has to go through an animator in order to filter the data. So, and then we create keyframes. Now this is the animation chunk. So how the heck character falls, how the heck character changes his clothes, how the heck character loads a weapon. Like there is if you take any game, there's like 50-60 animation would be there per character per weapon loading mechanism. So it's like how the heck it's supposed to do like this, or it's like everything. Like all these things are done in animation phase. So you took a mesh, you rigged it, you animated it, then you bring it to game engine. Now this is the most interesting part, and in recent years this has become democratized and free. Now you have what we have created so far, we classify that as assets. It's just things, they do not interact or react or anything like that, so they are just assets. So to take assets and add logic to it to make games is the job of game engine. Now you also add audio obviously, and then you have video if you are talking about cutscenes or pre-rendered animations and all that jazz. Then you are talking about 3D assets like buildings, cars and all that. And then you take scripts and physics. Scripts are like, okay, if person presses A, or run this animation, door opening or something like that, that will be controlled by basically scripts. So whole game is like basically fancy scripts one after the another. And then you're gonna have physics, basically how the heck character reacts, because again nowadays we are no longer in the world where it's like everything is pre-controlled. It's like, what happens if you blow a weapon here or fire onto this red barrel? All those things are controlled by physics engine, and that is also the job of game engine. Now there are two very popular game engines, which is Unity 3D and Unreal Engine. Now both of them are free. Now here's the read. Be mindful, when I specify free, I do not mean like they are 100% free. They simply means you can either pay for them and they can remove the watermarks and all the limitations, and you can make money out of it, or you can use the free one. But if you exceed a threshold where they're like, okay, now you're starting to make millions of dollars out of the free game, they're like, bro, you have to pay us. So free is very good for students, small time publishers and all that, and they only charge you once you make big. So you can, I'm definitely sure if you are a very avid mobile gamer, you must have noticed one or two games starting with the logo of Unity 3D. So these sort of things are done. And whenever you talk about like, I'm doing game programming, where the heck they are doing the programming? Unless they are programming the game engine itself, they are generally programming inside the game engine. They're creating quote unquote scripts. All the scripts are like logic gates, and the logic is like, if player presses X in this car, apply a handbrake, play the animation. All that jazz happens in the game engine department. Now once you're done with everything in the game engine, then you do final delivery. Basically you create a package. Now this package, you cannot just throw it in thin air, it has to be delivered. Nowadays online delivery is the primary method. So you can have Play Store, you can have Steam Store, you can have Epic Store. There are other also. There are some, they are like fine-tuned for indie gamers. There are some that are fine-tuned for retro gamings and all that jazz. So You have to think about those final delivery, and then you have to think about monetization and server maintenance. Nowadays almost everything is connected to server, and specifically if you are talking about games that are free but they have transaction built into them, like for example I liked one game, specifically Boom Beach. Now Boom Beach I could play for free, but I could pay for the coins, and coin I can spend in virtual. That means somebody in the gaming development department has to figure out how the heck money is going to be connected. Basically, what will be the payment gateway, how the heck I'm going to pay taxes, fees, charges, all that. Somebody has to sit down and do that. It's just not like a fun and games. Somebody has to do all that. So monetization is a big deal. Server maintenance, again, if it's a proper multiplayer game, then it's a hell of a headache. You could literally have a time where it's like, okay, 3 artists, 2 programmers made the whole game, and then there are 10 people who are just maintaining the server. Servers are very tedious to do. And then in olden days, like Mario, Nintendo, NES kind of era, Contra 2, Contra 3 kind of era, that's why I say it. Like once you get the product out of the gate, done. Nowadays that's not the end game. We start with bug fixing. Okay, these are the bugs that we missed. Okay, then you fix it. Then we talk about updates. It's like, let's say it's a free game and you want people to spend money, so you will add new components and all that jazz. So you will have to launch updates on a pre-done game. Then you also have to deal with DLC. So these are just the surface level step that goes into video game development, 3D one. So this was my presentation on a massive industry of 3D game industry. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I'll try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.